Hello, this is Colin and you're watching Grad School TV. In this week's problem, we have a project with a 5-year lifespan with some cash inflows, outflows, a discount rate and an initial investment. Do we decide whether or not to go ahead with this project? So here we have our 5-year span, starting with year at 0 and going all the way through to 5. Over here we have our expected cash inflows at the end of each year, the expected cash outflows at the end of each year, which gives us a net cash flow of $2,500. We have a discount rate of 11% and an initial investment of $2,500, which we will represent as a minus. Now what I've done here is used the NPV function of within Excel, the net present value function, but then we've also gone across here to do the manual calculation to see how this works from first principles and then see whether the two match. Now you can see of course that they do match. So how did we do this? First of all, we need to have our figure at year 0, which is this one down here. That's our initial investment. Then the cash flows are the same for the end of each year. They are the net cash flow from 4,500 less 2,000, which is 2,500. Now the cell reference for this one is $C $10, which is that one, which means that I can just simply fill those down like this, and it becomes $2,500 for each one. And then the net present value calculation is pretty simple. Equals NPV. The first one, C12, becomes the discount rate, which is 11%. The values are these ones here from the end of year 1 through to the end of year 5, not year 0. And then we finish that formula, and then we add this figure here, which is actually a negative, or we subtract the initial investment, in which case this would have to be a positive. We are still subtracting the initial investment, it's just that it's represented as a negative. And so that gives us a figure of $6,739.74. Over here, we have the same figures. So the initial investment is still cell C14, which is this one over here. However, this time I have manually put in each formula here for the discounted cash flow. If I double click in there, we have C10, which is this one right here, the $2,500 net cash inflow divided by 1.11. Next one down, the same cash flow divided by 1.11 squared. The next one down, the same cash flow divided by 1.11 cubed, and finishing it off down here to the power of 5, which gives us a sum of all of those present values plus the subtraction, or, well, I know that sounds a bit weird, but subtracting the initial investment, which is basically adding the negative figure. Now we can see here that the manual calculation equals the net present value Excel calculation. So why did we make a video? Well, because it's cool and you can see it in action. The question is, however, do we proceed with the project? Now, according to this decision rule, if it is positive, then yes, we proceed with the project. If it is more positive than another project that we are also considering, then we choose this one over that one. And if it is a net present value of 0, then we are somewhat indifferent. One of the things that's always troubled me about this whole thing, though, is how positive does it need to be? And, well, I guess that can only really be answered if you're thinking about it from your own perspective. You as the investment manager will only know that as you look at your project relative to the other projects you've taken on. But I still find it an interesting calculation. If the number's positive, you go ahead. Anyway, that's the calculation in action. You've been watching Grad School TV. Thanks for watching.